Hey everybody. Every so often I'll go on Alex and see some topics that you guys are all ready to work on or are working on right now, and I'll try to do some examples for you so a human works them out for you. You can hopefully that'll help you as you work through your topics. So these are some mixing problems. This first one is about mixing uh, interest-bearing accounts. So Angie has found some really great mutual funds here, some kind of account that earns a lot of money. I need to see who her money guy is and hire them immediately. But she deposited $9,000 into an account that pays 12% interest and 2,000 into one that does 7%. She didn't withdraw anything throughout the year. So we're going to see what the total interest she got in that year was, what the total amount will be in the account, and what is the percent interest relative to the amount deposited. So this all involves what's called simple interest, which is like a distance equals rate times time formula. So the amount of interest is the amount invested, so called the principal, times the annual rate times the number of years. Later on, we're going to use this and idea and expand on it to get what's called compounding interest formulas, but that'll be at the end of the semester probably. So first thing is first, we need to figure out what the interest is for each account. So on the one hand, she invested $9,000 into an account that earned 12% interest for 1 year. Of course, if we wanted to know how much she had in 6 months, we would put a half here. The t has to be in years because the rate is in years. And this comes out to be $1,080. Okay. The next one is 2,000 at 7% interest for 1 year, and that is what, 140. Okay. Then the total interest will be what you get when you add the two interests together, obviously. So that is 13,220. Oops, sorry, that's not right. 1,000. Getting ahead of myself. $1,220 interest. Okay. For part B, we need to know what the total amount is. So the amount is, you take how much is invested and then you add the interest to it. So in this case, well, later on we will, when we're doing the compound interest stuff, we'll notice that we can factor out the p and you get this formula here. But anyway, 9,000 plus 2,000 is 11,000 plus 1,220 becomes, here's my 13,220. Not a bad haul for 1 year of just not spending some money that you invested. Okay. Now, part C, the percent interest here they're talking about. Here they mean the interest relative to the amount invested. Okay, which just ends up being RT if you cancel out the P's. But that is 1,220 divided by 11,000, and that comes out to be about 11.1%. Note that if you are putting numbers into Alex, it'll say what to round off to. Don't round until the end if there's any rounding at all. For this problem, it may say you don't round anything and you put whatever you get, the exact number. All right, this next question is sort of a more general mixing problem, and I don't know if you're going to see one like this in your topics, but the technique that I'm going to use to set this up might help you later on. So here we're going to have a grocery store owner who mixes her own raisin bran. So she's going to mix bran flakes that cost $1.50 per pound, raisins that cost $3.25 per pound, and make a mixture that has 10 pounds of raisins. We don't know how many bran flakes, but the end cost should be $2.75 per pound without adding any extra fees. So the cost of the mixture should be exactly what you would get if you were to buy the ingredients separately and mix them yourself. So the general method here is you take the two types and they go on the top of these columns here, and we enter the rows at with what's given. So we have a per unit amount goes in this row. This is how I do it. And then the number of units goes here. And then you get the total by multiplying down as you would in the distance equals rate times time formula. So we were going to multiply down, but adding across will give the same answer for if you multiply down or add across. And so this will give you an equals an equation to solve here. So let's put in the stuff that we know first. We know that bran flakes cost $1.50 a pound and raisins cost $3.25 a pound. The mixture is supposed to cost $2.75. Now, how you enter the grid, how you enter stuff in the grid may change depending on the problem. But enter what you know first. We also know that there are 10 pounds of raisins. What we don't know, what we're trying to solve, is the number of pounds of bran. So let's make that x. If you add across, note that that means that the mixture must be 10 plus x pounds. Okay. Then we multiply down to get $1.50 times x for the total price, in this case, total price for the bran flakes, and then multiply down to enter in this one here. So 32.5 is equal to 3.25 times 10. When you add across, multiply down, what you would put in that last space there would be in the equation we need to solve. So in the end, we're trying to solve for x. 1.5x plus 32.5 is equal to 2.75 times 10 plus x, the quantity. And the way you solve an equation like this is you need to get all, simplify both sides, combine like terms, then get all the x's to one side and all the numbers to the other, and get x by itself on one side if possible. So let's simplify first by distributing 2.75 times 10 and then 2.75 times x. We already have a simplified left-hand side of the equation. Now I'm going to subtract 1.5x from both sides and 27.5 from both sides. That will get, sort of doing two things at once here, that'll get all the x's to one side and all the numbers to the other. 32.5 minus 27.5 is 5. 2.75x minus 1.5x is 1.25x. 1.25 is 5 over 4, so if we divide both sides by 1.25, we actually get a whole number. So you can use your calculator to find this, but it ends up being 4. So we would get 4 pounds of bran flakes with 10 pounds of raisins, and that will give us the right mixture. Okay, so I hope this helps you out this week or whenever you're working on this objective. If you have any questions, just let me know. Bye.